On number 25, it wants you to establish the identity secant u plus tangent u equals cosine u divided by 1 minus sine u. So, when you're trying to establish the identity, let's pick a side and work with it. We should pick the side that is not already in terms of cosine and sines, so let's work with this side. So we have secant u plus tangent u. Let's go ahead and convert that into sines and cosines. So secant is 1 over cosine u, and tangent is sine u over cosine u. So since they have the same denominator, we can add them together. So 1 plus sine u over cos u. Okay, so now we're sort of at a point where you could get lost. It's like, where do we go from here? Let's try multiplying the top and the bottom by the conjugate pair of 1 plus sine u. So multiply everything by 1 minus sine u. Okay, so let's try this. 1 times 1, 1. 1 times negative sine, sine u times 1 plus sine u times negative sine squared u, divided by, let's keep the denominator as 2 multiples. Okay, so we can cancel the signs on top. This and this cancel. And we are left with 1 minus sine squared u cos u times 1 minus sine u. Okay, so remember our Pythagorean identities? Remember the one that looks sort of like this? The one that's actually sine squared u plus cos squared u equals 1. Remember that? Well, we can actually rearrange it to look like this. So, cos squared u, subtract the sine over, equals 1 minus sine squared u. So, this is this, so we can substitute cosine in. Okay, so now that we substituted cosine in, let's cancel a cosine on the top and the bottom, and we are left with cos u divided by 1 minus sine u. Sorry. And this is what we were trying to prove it to look like. So we got this by first putting this in terms of sine and cosine. Then when we combined it into one fraction, we multiplied by the conjugate pair of the top. We FOILed the top out and canceled the inner signs. We switched this with its Pythagorean identity of cosine squared u. We canceled the cosine, and we finally ended up with the identity that we wanted to prove.